Endress and Hauser presents the world's first self-calibrating thermometer, the iTherm TrustSense with heartbeat technology. In the regulated pharmaceutical and food industries, the calibration of measuring devices is both standard practice and required by regulations. A modern biotechnology production plant for manufacturing medicinal products typically contains between 500 and 1,000 temperature measuring points, which all need to be regularly calibrated. This is a time-consuming and expensive process and involves shutting down the production plant, as all temperature sensors in the plant need to be removed and reinstalled as part of calibration. One important principle of calibration is complete traceability within the comparison chain. Each device that is to be calibrated is compared to a more precise external reference. This ultimately ensures consistent reference to recognized international calibration standards. Endress and Hauser has now developed the first-ever solution to integrate a high-precision reference with long-term stability into the thermometer itself. This is accomplished using a physical fixed point, the Curie point. The French physicist Pierre Curie discovered and gave his name to the Curie temperature, which is the point at which the ferromagnetic properties of a material abruptly change. This instant change in properties can be detected electrically, which enables the determination of the point at which the Curie temperature is reached. This temperature value is a material-specific constant that will not vary from its original determined value. The iTherm TrustSense uses this value in the form of a reference sensor consisting of such a material. This provides a physical fixed point that can be used as a reference for comparison with the actual PT100 temperature sensor. The iTherm TrustSense is available with a self-calibration point of 118 or 39 degrees Celsius, which is determined with extreme accuracy for each device prior to delivery. Each time a cooling process is initiated starting at higher temperatures, for example following steam sterilization of the plant, the PT100 sensor is calibrated automatically. Once the Curie temperature is reached, the reference sensor transmits an electrical signal. At the same time, a measurement is carried out in parallel via the temperature sensor. Comparison between these two values is effectively a calibration that identifies any measured errors with the PT100. If the measured deviation is outside of the set limits, the device issues an alarm or error message that is also displayed on-site via LED. The calibration data acquired is stored electronically in the device and can be read using asset management software, such as DeviceCare from Endress and Hauser. This also enables an auditable certificate of calibration to be created automatically. All known temperature sensors, including PT100 sensors, are subject to aging effects that can lead to drift. Longer calibration intervals increase the risk of undetected drift. Until now, these intervals have been determined by assessing the acceptable level of risk. Calibration is now carried out automatically in the iTherm TrustSense each time the temperature passes through the Curie point. For example, after each SIP or CIP cycle. These cleaning processes are typically carried out with every batch. This drastically reduces the level of risk, prevents plant shutdowns, and avoids calibration costs. This kind of continuous process verification has even become required by Good Manufacturing Practice, or GMP regulations. iTherm TrustSense. Risk reduction was never that easy.